Now today we'll be learning Laplace transform of periodic function. So what is periodic function? As you already know that a function, if it has the form f of t plus a is equals to f of t, then the function is said to be periodic. This function, it is periodic. Okay, so here for example you can have sine function sine t. Suppose ft is equals to sine t function. So if you draw the graph of the sine t function, so sine t function, it looks like this. Okay, so 0 to 2 pi you have this function. After 2 pi the same graph will be repeated. Okay, know that. So that means this 0 to 2 pi, this length 2 pi, it is called the principal period. Here this a, it is called period of this periodic function. Okay, so this is the understanding. Now see here, for sine function what you have, sine t plus 2 pi, it is same as of sine t. Okay, so here 2 pi is the period. So if you have this type of function, not only sine, there are many different type of functions which are under this periodic, okay, periodic setup. So how to find the periodic function Laplace transformation? So for that, see, if I am writing here f of t is equals to f of t plus a, that means this formula if I am writing, that means immediately a function, it is a periodic function. Now here suppose this is your periodic function, so in that case f of t, it is same as of writing f of t plus a. Again after a, that means a to 2a, the same function will be there, that is f of t plus 2a, and so on. Okay, so this is the generalized setup for a periodic function. Now if we want to find Laplace transform of periodic function, that means here we have the result, Laplace transform of ft is given by Laplace transform of ft, where ft is a periodic function. So in that case 1 by 1 minus e power minus as, here integral 0 to a e power minus st ft dt. This will be the formula for Laplace transformation. Okay, so you can note down this formula, that is for a periodic function where a is the principal period, or generally we call it as period. So in that case the formula goes like this: 1 by 1 minus e power minus as integral 0 to a e power minus st ft dt, where obviously s is greater than 0. Now the proof for this formula, it is quite straightforward. So if you want this proof, you can consider it. So Laplace transform of ft, it is given by integral 0 to infinity e power minus st ft dt. This setup we have. Now see here, integral 0 to a, you can break like this: e power minus st ft dt plus integral, here what you have, a to 2a e power minus st f of t dt plus here 2a to 3a e power minus st ft dt, and so on. Okay, now see, for this second integral, if you are taking, suppose for this second integral, if you are taking t is equals to u plus a. Okay, so in that case what you have, see, in that case, and also for the third integral onwards, if you are putting here for the third integral, if you are putting t is equals to u plus 2a, and similarly for the nth integral, if you are putting t is equals to u plus n minus 1 into a, so if you are putting this a, so in that case, but you have, see, in that case, that integral it becomes Laplace of ft, it becomes integral 0 to a e power minus s u f of u du. You can write like this. For the second one, see, for the second integral, what you have, this one, okay, with the limit a to 2a. If you have this setup, you are having this one and this one is the limit. Now you are changing this t by u plus a. Immediately, see, dt will be du. So f of t will be replaced by f of u plus a, which is same as f of u. Here e power minus s u plus a, and the limit will be, see, for t equals to a u will be 0, for t equals to 2a u value will be a. That means this will be the integrand form. Okay, so you have this one. Similarly, for the third integral, if you are putting this one, so immediately what you are having, 0 to a e power minus s u plus 2a f of u plus 2a du. Okay, so like that, if you continue with this setup, so what you have, see, 0 to a e power minus s u plus a f of u plus a du plus 0 to a e power minus s u plus 2a f of u plus 2a du, and so on. Okay, so if you continue like this, you have, so immediately what you have, see, integral 0 to a e power minus su f of u du plus here e power minus sa integral 0 to a e power minus su f of this part, it is nothing but fu du plus e power minus 2 sa integral 0 to a e power minus su. This part again, this is nothing but f of u du, and so on. So here basically what you are having, e power minus sa plus e power minus 2 sa plus so on integral 0 to a e power minus sa s, obviously su f of u du. Okay, so here, see, what you have, obviously this part less than 1, this part also less than 1, so this is nothing but this formula, see, 1 plus r square and so on. This is nothing but 1 by 1 minus r. So here exactly this formula you are going to apply, 1 minus e power minus sa, and here 0 to a e power minus su f of u du. This is nothing but Laplace of f of t. Okay, so this is the setup you have. Okay, so this is Laplace transform of a periodic function. So this was quite straightforward proof. Now we can take one question here based on periodic function. Okay, so find Laplace transform of ft is equals to sine omega t with 0 less than t less than pi by omega, and here 0 when pi by omega less than t less than 2 pi by omega. So now see, if you consider this graph from 0 to pi by omega, the function it is sine omega t. Okay, and from pi by 2 to 2 pi by omega, the function it is 0. So if you consider the graph of this function, so here what you have, this 0 to pi by omega. Okay, and after that pi by omega to 2 pi by omega, the value it is 0. Okay, again it will repeat itself after 2 pi by omega, that is 2 pi by omega. So again, but you have that same function. So that means here, see the solution. So solution, here the period it is, that is a value it is 2 pi by omega. Okay, so clearly this is a periodic function. Now Laplace transform of this function ft, it is given by integral that 1 by, that part you need to write first. So 1 by 1 minus e power minus s into 2 pi by omega, integral 0 to here 2 pi by omega e power minus s, give here what the function you have, f of u du. Okay, now we'll break this one, 1 by 1 minus e power minus 2 pi s by omega, here 0 to pi by omega e power minus su sine omega u du, plus here pi by omega 2 pi by omega e power minus su 0 du. Okay, so if you further do the calculation here, so immediately you'll get the answer as this part. You need to do the calculation. So immediately you'll get the answer as 1 by 1 minus e power minus 2 pi s by omega, here omega by omega square plus s square 1 plus e power minus su by omega. Okay, so Laplace of this you are going to get like this. Okay, so here you can write up to this. Now see the main part here, this integration you should do this integration carefully. Okay, integration by parts you can use. Okay, then you have to complete this solution. Okay, similarly there are many questions available for you. Just you need to take and apply this formula of Laplace transform for a periodic function. First you identify whether that function is periodic or not, and based on that you will do the treatment. Now next we are going to study inverse Laplace transform. Inverse Laplace transform, this is the continuation of our previous part where we have studied the Laplace of different type of function, Laplace transform of different type of functions, and standard formulas were there. Now to discuss inverse Laplace transform, the basic idea is that if Laplace transform of ft is suppose fs, then the inverse it is given by ft function, which is L inverse of f of s. Okay, that means if you apply L inverse both sides, you will be getting that previous function back. Okay, now Milne's formula, there is one formula known as Milne's formula. This is the essential formula to have inverse Laplace transform. Okay, so inverse Laplace transform, it is given by, obviously this is the basic understanding of inverse Laplace, but this Milne's formula or Milne's inversion formula, it is involved with the inverse Laplace. That means the function, it is given by inverse Laplace of f of s, that is given by 1 by 2 pi I integral here this formula is 1 by 2 pi I limit over this integral, that is gamma minus it gamma plus it as t tends to infinity e power st fs ds. Okay, this is actually Milne's inversion formula to find inverse Laplace. Now this intermediate step, it is involved with the with all the formulas. Okay, wherever we have the inverse Laplace transformation, already this formula it is embedded there. Okay, although it is not very much relevant for our practice, but you should know that this Milne's inversion formula is there to find inverse Laplace transform. Okay, now we'll directly move to the main part of Laplace inverse Laplace. So inverse Laplace transform of fs need not exist for all the fs. Okay, so there are few criteria under which one can find inverse Laplace transform. Now see, that is directly related with this Milne's inversion formula, but for our practice we'll be taking the general methodology. Okay, so general methodology means whatever the standard formulas we had, so just apply the L inverse both side and immediately we'll get back the main function back. So for example find ft if the corresponding Laplace transform is this one, k by s, if this is the question. Okay, so in that case how we'll handle this? See, solution, it is quite straightforward and simple question, that is f of s, it is given by k by s. So if you apply L inverse f of s, L inverse k by s. Now see, k is constant, so immediately you can write k L inverse 1 by s. So from this setup you know that L inverse, that is inverse Laplace, also satisfy linearity property. Okay, now you know that Laplace transform of 1 is what? 1 by s. Laplace transform of 1 is what? 1 by s. That means 1 is equals to Laplace inverse 1 by s. So here you can write k, that means your main function ft, it was this k. So this is the way we can find inverse Laplace here. Okay, suppose the function, suppose here this was the first function, suppose second function, suppose I am writing fs is equals to suppose s by s square plus s square. So directly what we will do, see, inverse Laplace, that is ft, it is L inverse of f of s, means L inverse of s by s square plus s square, and you know that s by s square plus s square, whose Laplace transform is this? This one is cos at. So this is the main function. Okay, so in our usual practice what we are going to do, we have the standard formula, we take inverse Laplace and immediately we'll get back the function. Okay, so first shifting theorem we had in Laplace. Now for the case of inverse, see the form of first shifting theorem. So if Laplace inverse of f of s is f of t, then Laplace inverse of f of s minus a, it is given by e power at ft. So e power at ft is nothing but Laplace inverse of f of s. Okay, so we can take one question here, find the inverse Laplace. Take this question, find inverse Laplace of 2s plus 1 by s square minus 4. See solution. See the process. First is fs. You write down this fs, 2s plus 1 by s square minus 4. First work will be, see, to find inverse Laplace, we usually apply partial decomposition method. Okay, this is one method. Another is what? Convolution theorem. Okay, so existence of inverse Laplace, that is guaranteed by the Milnes inversion formula. Okay, but to find out the inverse, we actually take help of either partial decomposition or convolution theorem. Okay, so partial, what exactly this partial decomposition is, that we'll be doing here. Okay, see, first work will be 2s plus 1. Here whatever you have in the lower term, just factorize it, try to factorize it if possible. Okay, this one. Now if you have this type of setup, see, this can be expressed like this: 2s plus 1 by s minus 2 s plus 2, that is a by s minus 2 plus b by s plus 2. So if you further do the analysis, 2s plus 1, that is given by a s plus 2 plus b s minus 2. So from here, a plus b is 2a minus 2b. If you compare both sides, immediately you will be getting a plus b is equals to 2, the coefficient of s, and the constant term, that is 2a minus 2b is equals to 1. If you solve this, and find out a and b value. So if you solve these two equation, but you are going to get, I think, a value is if you just multiply this first equation by 2 and then add a value, I think 1, and b value, it will be also, I guess, 1. So if you multiply this equation by 2, so you will be getting 2a plus 2b is equals to 4, and here you have 2a minus 2b is equals to 1. So in that case, a value should be 5 by 4. Okay, 5 by 4, and 5 by 4 a value, and b value will be 2 minus 5 by 4, that is 3 by 4. So a and b value you got like this. Okay, so immediately you can have this setup, that is, this one is nothing but a means 5 by 4 1 by s minus 2 plus 3 by 4 1 by s plus 2. Okay, now see, this is your fs function. If you apply L inverse both side, so 5 by 4 L inverse 1 by s minus 2 plus 3 by 4 L inverse 1 by s plus 2. So what you get? 5 by 4 e power 2t plus 3 by 4 e power minus 2t. That will be your ft function. Okay, so you got the idea. This partial fraction decomposition, this method we apply to simplify the function, and after that immediately one can take the inverse. Okay, so this is one of the important type of question. So another you can take, suppose another question. Let me write this question for you. Second one, that is find inverse Laplace of this one, 3 s square minus 2 square by 2 s power 5. This is your fs function. Okay, so first work will be just break this one whole square, that is fs is equals to 3 by 2, separate out this thing, s power 4 minus 4s square plus 4 by s power 5. So from here 3 by 2, that is 1 by s minus 4 by s cube plus 4 by s power 5. Now take inverse, that is ft is equals to 3 by 2 L inverse 1 by s minus 4 common L inverse 1 by s cube plus 4 common L inverse 1 by s power 5. Okay, fine. Now you have that formula, that is Laplace of t power n gamma n plus 1 by s power n plus 1. Apply this formula. According to that, if you just go with the calculation, what you will be getting, see 3 by 2, this is nothing but 1 minus 4, this is Laplace of t square, that is gamma 3 by s cube, that is 2 by s cube. So 1 by 2 t square, that is L inverse of 1 by s cube, that is t square by 2 plus 4 times here Laplace of t power 4, that is gamma 5 by s power 5. So gamma 5 means 4 factorial, that is 24 s power 5. So here 1 by 24 s power t power 4. Okay, this one you are going to get. Now if you simplify, you will be getting this final answer. Okay. Now this type of thing you have. Now change of scale properties, say in terms of inverse Laplace, those formulas or the properties are as it is. You can just take help of those previous lectures what it is already uploaded, and from there you will get the formula. Just apply inverse both sides, immediately you will get the answer. So it says that L inverse of f of ks, this is given by 1 by k f of t by k. This is change of scale property. Okay, so more or less all the formulas whatever we already studied, formulas or result, those things you need to go through. Okay, now here let me discuss another important point, that is inverse Laplace. See this important result, it is inverse Laplace transform of integrals. This is inverse Laplace transform of integrals. So for that, see, if you have Laplace of s to infinity f u du, that is given by ft by t. One integral, if it is given of this form, that is s to infinity f u du, that is given by ft by t. So one question I can give you from this, find inverse Laplace transform for this one, for 1 by 2 ln s plus 1 s minus 1. Okay, so here see the solution, half ln s plus 1 s minus 1. This can be written as half ln s plus 1 minus ln s minus 1. Okay, and this is nothing but half integral s to infinity minus du by s plus 1 plus du by s minus 1. You can write like this. Okay, so basically what you are getting, half s to infinity 1 by s minus 1 minus 1 by s plus 1 du. Okay, so this is nothing but your fu function. More precisely, if you take fu equals to half 1 by s minus 1 by minus 1 by s plus 1, and that is half s minus 1 minus 1 by s plus 1, you're going to get this. Okay, so now this is your fu function. Okay, so if you apply L inverse over this, so you'll be getting 1 by s minus 1 minus L inverse of 1 by s plus 1, which is nothing but e power t minus e power minus t by 2. Okay, this is nothing but sine hyperbolic t. This is your ft function. Okay, this is your ft function. Now see, L inverse 1 by 2 ln s plus 1 by s minus 1. This one, if you are going to do as per this formula, you should have ft by t. So ft is what? Sine hyperbolic t by t. This one will be the final answer. So how to find inverse Laplace transform of this one? Exclusively for this, you can take help of this formula, inverse Laplace of integrals.